What up, everybody? Welcome to Coffee Hour. My name is Paul Abernathy. Obviously, I'm in my book room, my library. Joining you today for Coffee Hour. Thanks for taking the time out of your day to join us. We know there's a lot of things you can do here early in the morning, depending on whether you're on the West Coast, which is really early, or you're here with us on the East Coast. It is 8 a.m. Eastern Time. That's when Coffee Hour comes to you Monday through Friday. Again, at 8 a.m. Eastern Time. We thank you for taking the time out of your day. Today is Thursday, July 3rd. We will not be having a show on the 4th of July. I want you to celebrate the 4th of July with your family and enjoy an extended weekend. Hopefully your boss is letting you off. And if you are the boss, let your guys and gals off. Let them enjoy a day with family. It's rare that it falls this way. Let them have that Friday, that Saturday, that Sunday to regenerate, recoup, and get out there and kill it on Monday, because you know they will. They'll be killing it on Monday. They always do. All right. So as always, folks, I live vicariously through you and how well you do, letting me know the successes you have, struggles you have. We're here together. We're here to give you motivation. I've literally helped thousands and thousands and thousands of people achieve success in the electrical industry through exam prep or through mentoring or training of some sort. So again, I always love to do that. So do me a favor. If you're joining us in the chat, please let us know who you are, where you're from, what you got going on. If you're a fast track student, if you have any questions, you're struggling with anything, and feel free to go ahead and ask that type of thing. If it's a very detailed question, then I'm probably going to send you over to paulabernathy.com so you can submit it through that portal, because it probably needs more thought. So that's just a place that I'll send you if you need to send us a direct question, and it will be answered either in an upcoming coffee hour, in a podcast, or even via email, that type of thing. One of the things that we talked about yesterday as we were talking about feeders was that you saw me go look at the cut sheet for an Encore wire when it came to an SC cable, a 333, I think it was, for an SCR. And you noticed that it was a 5 gauge for the equipment ground. And what I was looking for on that to see whether or not we had changed that, but that's still the industry standard. I don't work in the facility. I don't work in the plant. So that is standard through the industry. 5 gauge, again, it's larger than 6. So the NEC required a minimum of 6 for that product based on the overcurrent device that would be protecting it. Manufacturers choose to go with the 5 gauge. It's a little larger than a 6. But it meets the code requirement, and it also meets the UL 854 requirements for sizing. Okay, not more than a certain size down from the insulated conductors and things like that. And this would typically be the uninsulated equipment ground. So it's all part of the UL 854. It meets the standard, and most of the manufacturers do it. Now, are you going to be able to go around and find a 5 gauge standard anywhere? No, you're not. It's going to go from 6, and it'll jump up to 4. It's rare for you to find a 5 AWG, so don't go hunting for it. It's something that the manufacturers are allowed to do, and it's part of our UL 854 standards, because when you buy that cable, you're buying a pre-made assembly. Okay, you assume that we've done all of our due diligence on the production of that cable, and we have. It's just a little bit bigger than what the NEC would say is required for that equipment grounded conductor, and that's okay. It's okay to be bigger, just can't be smaller, right? All right. All right, let's reach out real quick and do some shout outs to folks, and we'll get into today's lesson. By the way, today's lesson, we are going to talk about panelboards and just kind of look at some nuances about panelboards. Feel free to ask any questions about panelboards, Article 408. We'll go look at the NEC where necessary, and we'll even use the hog if we want to try to figure out something that you may ask in the questions, and we'll do that as well on the show, because we like to be well-rounded here in the morning, get your day started. I have a blend of Dunkin' Donut blend, so that's what I had this morning. I am out of it, by the way. People behind the scenes can see that, but you can't. All right. Behind the scenes, by the way, we do want to have a shout out to all those over on TikTok who are watching behind the scenes versus watching the actual show itself. All they see is the keyboards, the mics, and the keyboard and screen and all this kind of stuff. But we encourage you, come on over, watch the stream. That way you can see the presentation and get into the discussion, because I don't answer questions on TikTok, okay? I answer them right here in the live stream, all right? So let's do some shout outs real quick. What's up, Paul? As always, are you off that lift today? Back in the office, hopefully. What's up, Marlon? Glad to have you here, my friend. Thanks for joining us as always in the morning. What's up, new place? This is your new place. So glad to have you here. Adam. Adam is going to be venturing into the CMECP Journeyman program. Same as the master's program. The only difference, you get longer time. And a prerequisite is that you have to become a master by the end of the 12-month in this program once you sign up. So it kind of is a learning program. It saves you having to buy a separate course for exam prep. It's all rolled into one, but you still have the same stringent requirements for the end units. Still have to pass them with 80%. Still have to do everything in the normal. You just get a little longer to do it. The only way you can get into that program is if you're a journeyman. Masters cannot get into that program. Masters have to go into the regular 4-month program. All right, so good luck there, Adam, if you decide to jump into the program. What is up, Irvin? Thank you for joining us. Glad to have you here. We're still doing our shout outs here. Seattle, whatever it is. Appreciate you. Glad you're joining us. What is up, Jason at Beans Garage? Thank you, Jason. Thanks for joining us. Jonathan's joining us here. Battles Electric. Thank you for joining us, as always, this morning. Glad to have you here. Absolutely. Jonathan says, happy birthday to the greatest country ever. Absolutely. Greatest country ever. I'm glad I did not give my outcome yesterday on the Diddy trial because it totally was different than what I thought it was going to be. Basically, that's all you got for being take that. All right. So anyway, let's see here. Jonathan, fast track student. Absolutely. What's up, Greg? Glad to have you here. Yan and Nikki, glad to have you here. Good morning over on our YouTube channel. Glad to have you here. Dan is in the house this morning. Glad to have you here, Dan. David A. David A is in the house this morning. What's up?
Woo, 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 woo. Big dog.
There we go. Let's see here. What do we got? Robert. Good morning, Robert. Glad to join us down here. What's up? Red Dog.
Woo,
in the house.
Woo, woo. Big dog.
Thanks for joining us, Red Dog. The actual jig for the license plate things. It reminds me because you're one that won one of those. Actually supposed to arrive today. Also, our slate is supposed to arrive today, so that's going to be cool. I'll share that with you as well. Jonathan says, could you do some solar? Not today. Today we're talking Panelboards. But if you want an episode for solar, let me know what part you want. Am I going to do the entire 690? Absolutely not. But if there's portions of it you want, just go to paulabernathy.com and submit your topic that you would like us to talk about. Anything you want us to talk about when it comes to solar. Be able to do that. These typically shows, we have pre-scheduled things that we're going to talk about. So I'm not going to just deviate from Panelboards and go into PV, that type of thing. So, but yes, if you want that, please submit it. And we're more than happy to try to talk about any topics you want. I tell PV, it seems that people love PV, but it is not nearly as complicated as people make it out to be. It is not. And I'm not sure what about 690 causes so much confusion for people, so again, more than happy to talk about it. It's really not as complicated as people want to make it out to be, but more than happy to. It's really code driven. You just got to know where to go to look in the code. But we'll more than happy to talk. I guess in PV, most people get confused about is conductor sizing, overcurrent protection to sizes, rapid shutdown. They don't understand rapid shutdown, the disconnecting requirements. Other than that, really, it's really just look at the code and do what the code says, that type of thing. But definitely, Jonathan, we will cover that. If you want to talk about, just give me kind of an idea of what you want to cover. I don't want to do a whole PV episode, but let me know what you find of interest to you. Most certainly, we'll cover that. Let's see here. Got a lot of wins going on. In here. What's up, Manny? Thanks for joining us, Manny. Remember again, #win, get you in on the spin. Now the third quarter drawings are being done. We're putting together the actual out of the hat drawing for the quarter 2. Should come the end probably now since Friday. I think that put a kink in it because I have other things that I need Jeff to finish and I'm working on. So it's probably going to be next week where we'll do the drawing out of the hat. And then it will be much quicker because you'll get an email address on where to send it if you won, and it'll be all quicker. But everything, I believe everybody got everything from the Q1 and Q2. I believe everybody got their stuff. So good morning, Manny. Love the green code nerd. hoodie, as always. What's up, Jay? Glad to have you here, my friend. Pedro's in the house. Welcome, Pedro. Glad to have you here. David Carter's in the house, ready to learn. That's what I'm talking about. Let's go. Pete, welcome. Glad to have you here, Peter. Let's see. All right. So what we're going to talk about today. Now, the last 2 days, Monday, I think it's Tuesday and Wednesday, we talked about feeders and all the little nuances about feeders. And of course, feeders are going to be feeding load centers in residential, which we can still call panel boards. It's fine. Panel boards are really the guts that go inside of the cabinet. It's a little more versatile. Panel board really is made up of a bunch of different components, whereas a load center is a smaller compact system that you buy, and it's typically what you get in residential. We call them load centers. But I think everybody knows that if you call it panel boards, panel enclosure, service and cabinet, whatever, we all know what you're talking about. But just so you know, typically load center is what you're going to find inside of a residential setting. Usually they're plug-on breakers for load centers. Panel boards could be plug-on as well as bolt-on. Usually in commercial, we see more of the pieces that go together in bigger cabinets, and they incorporate a lot more components. And so panel boards under UL 67 is actually made up of multiple components that come together under the UL listing. But just think of commercial panel boards as a little bit bigger, a little more wiring space typically. But can you see load centers in a commercial application? Sure you can. Is it okay to call a load center in a dwelling or residential a panel board or panel cabinet or panel enclosure? Sure it is. It's fine. They're pretty much synonymously used, but there are differences. Of course, they're defined in Article 100 of the National Electrical Code. Load center is not defined. A panel board is defined, okay? And it's basically made up of some components, pieces, elements together with buses and the panel board guts that the actual breakers will connect to. And then you have the cabinet that it all mounts into, and all that gets evaluated under UL 67, things like that, okay? But I think what you see mainly in your residential is going to be really, they're pretty much categorized as load centers. But again, call them panel boards, it doesn't really matter. But in commercial applications, while you can see them in light commercial applications, typically medium size and large commercial applications, we typically want to call those panel boards, panel board enclosures, that type of thing. Okay. All right. So today is a little shift since we were talking feeders yesterday and the day before, we were talking more residential feeder, SERs and things like that. So now today we're shifting, we're going to talk about panel boards in general. And it is also going to apply in many cases to load center applications, especially the configurations. So it's kind of crosses both bridges here today, but we definitely want to focus mainly on talking about panel boards. And I'm going to read you some language out of our course material that we have. This was out of the commercial program, which we don't carry anymore, but it is out of that program. So that's the reason why I want to read it from the program, since it is published information, but it's just not in a course that we provide anymore. And the reason we don't provide the course, residential and commercial, because again, I'm all about numbers. I'm looking at traction in which courses, and we want to focus on what we do best. And it seems like we didn't sell enough of those in order to make that worthy of continued support. So anybody that currently has those, we support it, but no new ones are being sold. With that note, also, you may notice on our mobile app, the chat now feature is gone. We did a study. We went and saw how many people logged into that and used the chat feature on the mobile app. And y'all know how I am. If I don't see a lot of activity, I remove it. I get rid of it. And that's what I did. I got rid of it. So you still have everything else on the app, normal features, normal functions, everything. But we made room on there to add a couple more features that we want to add that we're not ready to talk about now, but we'll be adding them to the mobile app. So we had to make room. So the chat now feature, which was rarely used because y'all are not very chatty, we got rid of it. Okay, so if you go there and you notice that, you'll notice it's gone. Okay. Let's see here. It says, I wish they would make a resi panel without KOs. For example, adding a panel to a home shop with a conduit. I would love to make my own holes and line everything up. Well, you know, I I can't say. I mean, I'm assuming. I guess they don't make one. I don't know. I really don't know. I've never really looked. I don't know if you could buy. Uh, I don't know. Maybe all the load centers all come with KOs, and all of the commercial type of panel board configurations in the cabinets all punch your own holes. Hey, I don't know. There may be some manufacturer out there that makes a load center with no holes in it. I don't know. Now, when you say, and I don't know how big of a thing it is, to be honest with you, because other than somewhere like Chicago, which doesn't seem to like MC and doesn't like non-metallic sheath cable, and everything they like is rigid in homes, all right, I guess that may be a thing. But everywhere else, they're going to use non-metallic sheath cable or MCs or something flexible, cable assembly, something like that. So probably not going to matter. And probably many people rather have the KOs. So I don't know. I'd have to really look to see if you could buy a panel board and use it in a residential application. I don't think it's a violation to do so, as long as that panel board and that assembly that you're buying in a cabinet doesn't say that you can't use it in a residential setting or that the voltage don't comply. So I don't know that would be I would think you could probably use a panel board set up out of a commercial. I mean, what is commercial? Okay, so it might be just a voltage difference, but I think I would look into that if you want to have one of those and see if you can't do it. If you want to install something that would typically not have KOs in a cabinet with a panel board in it in a residential, just look at the markings and see what the listing is, or reach out to your manufacturers. Reach out to Eaton and Schneider and ask them. They're going to know better than I would know. I never really gave it much thought. When most residentials I've ever done, I'd rather have the knockouts. You know what I'm saying? Franks, what do I think about the Eaton's retrofit panel boards? So these are the guts, the panel board, the guts that can go in. For example, what Frank is talking about is, I remember back in the day when I was doing engineer design, we had existing buildings that had existing Federal Pacific panels, and they had the cabinets in them. And they wanted to get rid of all of the guts, the panel board itself, keep the cabinet. Cabinet was fine. There was nothing wrong with it. And so they would remove the guts. And then Eaton makes a retrofit panel board that's designed, if you give them the dimensions, it will fit inside of the existing cabinet. Again, they need to know the dimensions because you have a certain 312.6 clearance that you have to have from the breakers to the side where the conductors come in, or in the bottom or the top. So there is a space issue. And so they need to know all these dimensions, but they do make an aftermarket panel board. And I don't care. Like I said, I think that the cabinet is irrelevant. I think it's a metal cabinet as long as it meets the sheet metal thickness requirements. You know what I'm saying? All of those requirements. Then I don't think it matters as long as I have clearance. I think that the Eaton's replacement panel board guts work great, and they can be a great thing if you're in a retrofit application and you're trying to remove an old system and you want to replace it with newer breakers, those type of things, and maybe an old fuse setup that you want to replace with circuit breakers, and they have a replacement panel board to go in that, and you can get all the clearances within the enclosure. I think it's a great thing. I think it's a great product. And most people know that I helped start the Eaton ECCN program years ago. I was their first educator who traveled the country in that scenario. I forgot to turn this off, folks. Sorry about that. People try to call me early. So I helped start that program. And one of the things that we talked about all over the country was those retrofits and how to use those retrofits. Okay. Let's see here. Just use wire waffles. Speaking of that, speaking what Adam says, here's the wire waffle. Word of the day, wire waffle. Interesting. I watched a video. The bearded inspector was doing another video, and he was talking about these for that guy in Arizona who says, they allow me to do it in Arizona. And I'm sitting there really thinking, I'm like, first of all, it always has been an issue where I didn't care whether or not a jurisdiction allows it or not. I don't care. I just go by the NEC. NEC says that all cables had to be secured to the cabinet with the exception. And under that exception, most of those applications where they come in the back or anything like that don't meet the exception to 312.5c, right? So that's when Hunter and them came up with this. I think it's a great idea. I wish I had thought of this myself. Okay, it's not nothing more than a blow mold, but they did it. Okay, so the fact that Arizona may have some small jurisdiction in Phoenix or somewhere may have an amendment or something that they allow these or don't allow these. They let you bring them all in as long as you seal the opening. That's fine. That was never my argument. And again, I remember the Cy Porter and all them went crazy. That was never my argument. It was never my argument that if a jurisdiction wants to amend something, go for it. I don't care. I'm all about what the National Electrical Code says. And the National Electrical Code does not have an amendment for you to be able to come into the back of a panel outside with all these NMs. Okay. And what they also don't talk about is they let you come into the back of the cabinet in Arizona with all your non-metallic sheath cables. But if there's a gap in there, it's running through a raceway coming into the back when you still have non-metallic sheath cables in a wet location. They're outside. So, in some of those amendments in Arizona, they say, well, as long as the raceway is at least 3 inches so that, that type of thing, whatever. But it just so many, you can just solve so many problems with this. Now, this doesn't solve the problem in Arizona. This doesn't still solve the problem, by the way, and I hate to tell this to Hunter and them. This does not solve the problem where you still have an exterior panel and you're bringing all of them into a panel from the inside out that would go through and be open in that little 1/4 of an inch gap that's required between the panel and let's say the wall. You have that gap, then you would have non-metallic sheath cable exposed for a little bit outside, and that's a violation in itself. So this doesn't solve every issue, that type of thing. So it's kind of funny because I tried to make a recommendation to Hunter and them, and I don't know whether they watched the show or not, but I said you need to make one of these that has an extended sleeve so that it can snap onto these little holders right here, these little holders. Because if you're using it this way, they connect in, and then you got these on the other side that are free. You need to make something that'll snap onto like a tube that comes out, right? And the reason for that is if you snap it onto this, we'll say it's part of the fitting, and it's not a raceway. Because if it's a raceway, then you can't have the NM cables in there. It'd still be a wet location. But if it's part of the fitting, extends it out, then you can argue that it's part of the fitting and it's not a raceway, and then you have an argumentative point there, and then allows you to be able to bring them into the back through one of these, okay? I just give advice and, how things could be argued and challenged, that type of thing. But anyway, so that's a wire waffle. For those that got your wire waffle, let us know how they work, okay? Send me some pictures of your install, how they work. Okay. If you have any questions about wire waffle, let me know. I'm more than happy to explain it. I don't charge Hunter and them. We don't get anything from promoting this. I think it's just a great idea. That's all. Just a great idea. Absolutely. Let's see here. What do we got here? Craig, we got here. Good morning from Nashville before the long weekend. Hopefully everyone day goes well. Y'all have a great weekend. Absolutely. Remember, we are not going to have a live show tomorrow. We are going to be a recorded show. Thomas, absolutely. Overthinkers. Some people think too hard, and it makes things complicated. Oh, by the way, before I say anything, I want to make sure, folks, make sure you go visit Fast Tracks Tube. If you're a subscriber, we uploaded a couple new videos over there. Go check that out over on Fast Tracks Tube if you are a subscriber. If you're not, think about subscribing. It's $99 annually, and you get access to all the videos, that type of thing. All right, where are we at? Okay, that's the good mornings to everybody. Let's get into the lesson. All right, introduction. What are we going to talk about today? We're going to talk about the installation of panelboards is always a part of new building construction, such as a commercial building. After a building is occupied, some additional equipment may be installed, such as more energy efficient lighting that may actually reduce the existing load. Again, what they're talking about is you could have an existing building. They come in later. Somebody wants to come in and retrofit out and take out some fluorescents and maybe put LEDs in, things like that, which is going to reduce the load capacity on the building. But they could also bring in additional loads into this panel board that will increase the loads on the building. The electrician has to be keenly aware of that and assuming that the design professional designed it for actual additional headroom. Okay. They're not required to do that, but a lot of engineers, for example, if I'm going to come up with something that is, and we saw this the other day with the feeder, if my values came up to a certain value, why would I not just jump up to the next standard size and size the conductors up to the next standard size? For example, in our last example, we said feeder was a 3, which I believe was 100 amps, or I could jump up to the next size and then I could go up to the 125. It gives me a little bit of headroom, that type of thing. So why would I not do that? Even though I have a load calculation, go a little bigger on the wire, go a little bit bigger on the gear, and it just gives you some expandability, right? That's the kind of thing. Now, here it says the electrician should be able to determine if the design will permit additional loads. We talk about this a lot, whereas an electrician will have to do what's called an existing load calculation to determine what's existing and what additional room they have. So in an upcoming episode of Coffee Hour, probably next week, one day next week, we're going to look for it. We're going to do an episode where we look at an existing load center or existing panel board, and we determine if we have enough room to add some additional equipment. So we're going to be looking at the NEC, what it talks about that, being able to go into something and say, hey, for dwelling, for example, somebody says, well, hey, I want you to come in and put this EV. And you have to calculate and say, do I have enough room to put this EV? Maybe this EV has a special feature where I can management control system where I can control it down so that I have enough room on the existing service. Whereas if I used it totally at its 50 amps, is that going to put me over on my service calc? Is there a way that I can dial it back? Yes, the car won't charge as quickly, but it would allow me to put it on there without having to do a brand new service upgrade, which can get costly. All they wanted was to charge their car. Maybe it's a little better than a standard plug-in to 120, and you plug in and 20 amps or something. Maybe this gives them a little bit more, maybe a 30 amp at 240 or something like that. So a lot of these new systems have the ability to lock things out, and 625 gives you provisions for that. And so it may give you that additional headroom to be able to program it and lock it out at a certain amp value that is not going to overtax the existing service. But you still need to know what the value is on a service. You can't just look at it and say, oh, there's enough room in there to add additional loads. You got to do a calculation, right? And you need to know how to do the calculation, okay? So we're going to talk about that hopefully next week in one episode where we just kind of look at the head and see if there's any headroom on the existing service, things like that. And we could do the same thing for a feeder application. It's all going to be very much similar, that kind of thing, all right? Anyway, so you got to be able to look at that as an electrician and know that I'm not just going to just keep adding things in it, right? I just can't take a 200 amp service and add multiple 100 amp remote distribution panels just because you can. Should you? And have you done a load calculation to tell you that it's okay to do that you're going to be well within the use? Okay. So we'll talk about that on another show, but you need to be an electrician that knows how to do that. Okay. What's up, Angel? We got multiple angels in here. What's up? Both angels. Welcome. One is on YouTube. One is on Facebook. Thank you for joining. I am doing great today. Thank you. All right. Let's get back to the lesson. Now, a new panel board. Okay. Now we're going to be talking commercial today. So we're going to stick with the term panel board rather than call it load center. So we're going to try to shift gears into running a feeder, let's say, to a panel board in a commercial environment today. Kind of shift the gears a little bit on us, kind of mix it up a little bit. Can't have all the resi guys getting all the love. We need to mix it up a little bit. Okay. So a new panel board need to be installed at a later time that will satisfy the needs of the occupant. Okay, makes sense. All right, let's talk panel boards. Okay. Okay, so separate feeders are required to be installed from the main service equipment. So we're going out from the service equipment out to these panel boards in various locations in the commercial building, right? To each area. And again, so what I like to do first, and I'm sure everybody knows this, but I like to make sure that for anybody that's new, that asks about the terminologies, because we use the words feeders. I hear people say service feeder. I hear people say all kinds of things. I hear people, again, call service conductors feeders. let's kind of get the lay of the land first. I like to do that. So we're going to do that by looking at a figure. And I'm going to try to make this a little bit easier for you to see. So we'll start out right here. Y'all all can see this. So here's the utility transformer up here. Okay, it comes down. We're at the secondary side. It's coming down into the service equipment. Okay, if you got any questions, feel free to ask too, guys. So here's the service equipment. Okay, this is the line side or supply side. This right here is a supply side. Okay, right here, supply side jumper. Okay, all right, and down here, this, for example, this right here, this little jumper right here would be a load side jumper. Okay. Now, I don't know the reason they're doing this because this is a feeder. So I'm going to assume that this is over 250 volts to ground. But again, it's just for an illustration to show you all the pieces so we can call it out. So this would be like a load side. Okay. This would be a supply side bonding jumper. This would be a load side. This down here, you notice that this is a service, by the way, and you're saying the grounding electrode is here. Conductor goes to the neutral bus as required in 250.24. But you do notice that this looks like it's floating. Well, this right here is a wire that's connecting the connection to the box to the grounded neutral conductor. And this is a main bonding jumper right here. This is just the green screw at this point that connects this bus to this cabinet, but connecting this bus over to the neutral bus, this is a main bonding jumper, and it's of the wire type. So we have to calculate this. Now, could I have eliminated this right here and just put the green screw over here? Absolutely, you could. And if that's the case, then that green screw is the main bonding jumper, okay? That type of scenario. But again, this one is sized right here based on these conductors that are supplying it. Okay, right here. All right, just wanted to lay that out there. In case anybody questions an illustration, I told you all the time, we use a bunch of different types of illustrations to it'd be too easy to put everything on the one bus, okay? So it makes sense to break it up so that we can have these talking points, that type of thing, okay? All right. So this right here is your overcurrent protection, and it goes out. And this right here is this is a main lug only panel. Oh, you can't see it. Hold on. Right here. So this is a main lug only panel. Perfectly fine. Okay, this could be in your basement. This could be in another room of your house, whatnot. Okay, so now I got a trivia question for you folks because we're talking feeders. If this was to a detached structure now. This is a remote garage somewhere. Let's see how you are in the comments, folks. Is this main lug only panel acceptable? If this is in a remote structure, is just having a main lug only acceptable right here? In this scenario, is this acceptable? Yes or no? Let's see what everybody says. All right. This is kind of interaction, folks. Hopefully y'all are watching. You can interact with me. If you're driving, don't do it. Don't try to do nothing while you're driving. That ain't necessary. But in this illustration right here, and if it is, tell me why it's okay. Tell me why it's okay. Remember, this is a feeder. Okay. Manny says, yes, this is okay. Okay. All right. Everybody else? Anybody else say why this is okay to have the main lug only right here? All right. Marlon says no. Okay. Be a good little lesson. We're talking feeders today. And I'm just kind of throwing some stuff out there here. It's coffee hour, having a conversation early here in the morning. So, all right, so let me go into this for you real quick. So if this was inside of the dwelling, it would always be okay because you have protection here, right? Right? Protection here, okay? So if this was in the same building, in the basement, okay, it's okay. Not a problem. Now, if this is a detached structure, and we're talking about the feeder application, so you still have this rule right here. You see, how many breakers do we have? 1, 2, 3, 4. We have 4 breakers, only 4, okay? So let's go over to the NEC. Great opportunity to talk about these type of things, okay? So let's go to 215 real quick. This is just feeders. Okay, And that's conductor sizes, yada, yada, yada. Okay, overcurrent protection. Okay. All right. We have all this overcurrent protection layouts and everything like this type of thing. All right. Let's just kind of scroll down, see if there's anything that's beneficial for us down here. Hold on here. Identify. We don't care about that. Let's go down. We don't care about that. Like right now, anyway. Looks good, right? Nothing in here, right? All right. But remember what I said? Where's this feeder going? This feeder is going to a detached structure in this case, right? So you looked at 215. That would be great if it's in the building, right? But we got to go look at 225. And we go look at 225. Let's see here. Let's see here where we want to jump to. We're going to jump to right here. Part 2 of 225. Okay. All right. So what does it say here? It says number of supplies. So a building or other structure that is served by a branch circuit or feeder. Ours is a feeder. Okay. On the load side of the service disconnect, that is what we have, right? It's being fed from the dwelling over to a detached structure. In this example, the question I ask you, all right? So it's supplied by one feeder. Yes, it is. Okay. Now, talking about when it can be supplied by more than one, you've got some allowances here, just like you do with services. You do have some allowances when you can have more than one supply to a structure or building, right? But we're going to come down, and we're right here, the disconnecting means requirement, okay? It says, means shall be provided to disconnect all ungrounded conductors that pass or that supply or pass through the building or structure, right? Okay, right here. The disconnect means shall be installed either inside or outside of the building or structure served, or where the conductors pass through the building or structure. The disconnecting means shall be readily accessible location near the point of entry of the conductors, okay, for the purpose of this section, right? So let's just clarify. They came from the dwelling, or building, whatever, went down, went out, went underground, came up, and now we're at that panel at that detached building or detached structure, okay? Okay. All right. So we know we need a disconnecting means. We know that. Okay. All right. Now, if you go down and look into the allowance, the maximum number. Okay. So the disconnecting means for each supply permitted in 225.30 shall consist of not more than 6 switches or 6 circuit breakers mounted in a single enclosure. Okay. Or they could be grouped in separate enclosures. Right? I forget, folks. I am not showing y'all the code. Sorry. All right, here I sometimes get caught in not showing you what the code said. So here is 225.31. So remember, we're an outside branch and feeder because it went outside, right? And it says means shall be provided to disconnect all ungrounded conductors that supply or pass through the building or structure. So we know we need disconnects. Okay, can't use the main lug only by itself, and we're not in the same structure. We're in a detached structure right now. Okay, so I have to have the disconnecting means. Now, it says that the location of them can be just like at the service, inside or outside the building or structure, or where the conductors pass through the building or structure. Okay, it has to be in a readily accessible location. Well, in our picture, it was. It comes straight in, came up, and it's coming straight into the detached building. Okay, so now the maximum number. The maximum number that we're going to have, it says the disconnecting means of each service supplied by 225.30. And by the way, that is this. This is one feeder that we're supplying to this panel in a detached building. Okay, it's not, this panel's not in the same building. It's in a detached building in this question that we've been talking about. Okay. And then the question was, does it need a main breaker, or can it hit a main lug only? And some people said yes. Some people said no. Reality is perfectly acceptable to hit a main lug only and have, in this case, there's only 4 breakers in there. So this one is compliant. 6 throws. Now, the reason that some people get confused with this is because this disappeared for services. You can't do the 6th throw in one single enclosure and be compliant. That only applies to services. Does not apply to feeders, okay? In case you didn't know that, right? So there you go. So now once you get right here, then these are the last overcurrent protected devices. They go out to the branch circuits. They go out to the various loads. You have some various loads over here. Motors, lights, receptacles, all that kind of good stuff, right? Okay, so that kind of gives you the layout of what we're doing. So again, the feeder is on the load side of the service equipment. A feeder is going to go out to typically another panel, and that panel is going to have the overcurrent devices in there that are going to go out to the branch circuits. That's the last, from the last overcurrent protection device out to utilization equipment or receptacles or lighting loads or specific motor loads and all that kind of, those are branch circuits. The reason I bring this stuff up is because, for example, a range or anything like that, a water heater, all those type of things, those are typically just branch circuits. And people use the terminology feeder. I'm running a feeder to the range, or I'm running a feeder to the water heater. It's not. It's a branch circuit. Okay? So keep that in mind. Even if I have a pull-out disconnect for the actual water heater, let's say, because it's not within sight of the panels, and we're not going to use the breaker, if I use a pull-out disconnect, let's just say, then that doesn't change the fact that it is still just a branch circuit. All that is a disconnect. It doesn't change anything. Okay? All right, now, basically, feeders are the conductors between the main building service and the individual distribution panels. We call them remote distribution panels downstream. We don't really use the term sub-panel, but some people do, and it's okay. It's perfectly fine if you want to use it. Everybody knows what you're talking about, okay? And that is where the final branch circuits, circuit breakers will be located. And then, of course, then it just branches out to all of the different loads that you have. Each feeder will terminate in a panel board that generally is installed in an area to be served, okay? Now, I don't know what this figure is, so we'll bring it up. There you go. So here you go. So this is typical your panel board. So this one here happens to have a main, right? And this one happens to have a main lug only. If these are in the same building, look at what we've got here, the sheer number of breakers. If this is all within the same structure, then I can go from the panel and then the protection from here out to this panel, maybe from a 3-pole breaker like this one right here, then I only need to use main lug only, okay? Then I can have the separate breakers in there, okay? Perfectly acceptable. If this panel right here was in a detached structure, it wouldn't work because I have more than 6 here, and so I'd have to have a main breaker on here, or I'd have to have a separate disconnect outside or adjacent to this panel in order to comply with the rules that we just saw in 225, okay? But if they're all in the same building, dude, I can have main lug panels downstream of the main panel, fine. Why? Because they're protected up here at where the circuit originates, where the feeder originates. It's protected. Where is this also allowed? In 408.36 allows that protection to be upstream as well for that panel board, okay? All right, so there you go. Now, panel boards to the left, right here, is the main breaker panel board. Plus, it has many other individual branch panel boards. It might even have a feeder breaker, okay, that's still classified as a branch circuit breaker, but it could supply a feeder here as well. But as far as its classification, you don't typically see them classified as a feeder breaker. And it says that one. And then the panel on the right has branch circuit breakers only and is referred to as main lug only, okay? There you go. Okay. Brian's boat. I got fast tracks last night. So far, so good. Awesome. Work in it. Make you do those competency reviews and be honest with yourself. Don't cheat. Don't look at the answers. And be honest, the ones that you get wrong, go back and read why you got them wrong. Spend that time. Spend that time in there. It's not a race. Take your time. Absorb that info. Okay. Now, this is definition straight from the NEC, by the way, folks. So here's what it says. What is a panel board? It's a single panel like this, or a group of panel units designed for assembly in the form of a single panel. Okay, so you could have a bigger cabinet with multiple panel boards in it. All right, that would be perfectly. And that is a difference between typical a load center and a residential. It's just one cabinet. Whereas a panel board could be one, or it could be a combination of multiples, that type of thing. It says a panel board also includes the buses and automatic overcurrent devices, circuit breakers, and equipped with or without switches for the control of light, heat, or power circuits. Okay, so you could have a panel board that also has other elements in there, other switches that are other than just a typical circuit breaker type of scenario in that scenario. All right. Let's see here. Designed to be placed in a cabinet, enclosure, or cutout box, placed in or against the wall, partition, or other support, and accessible only from the front. Okay. Load centers, by the way, are also only acceptable from the front. Another thing is you typically can get a lot more capacity out of a panel board setup in commercial than you would a load center. They're usually very limited in their loading, whereas you're not so limited with a panel board setup under UL 67 that's typically used in a commercial application. Let's see here. As indicated in the definition, panel boards are busing and overcurrent devices that are mounted in the enclosure, such as a cabinet. Okay, we usually get a metal cabinet, and this panel board will mount into the cabinet. All right. The installation of a cabinet is covered in Article 312, and a panel board based on Article 408 is installed inside of the cabinet. Now, remember, load centers, you buy it just one piece. Everything is already in there, that type of thing. So that's typically you can get. I've done some large commercial applications where I've had multiple panel boards, the guts mounted into one larger cabinet setup. And it may have separation with certain partitions and things like that, but it's a little bit bigger configuration. Let's see here. This provides some overlapping requirements as the general rule on the construction and installation of panel boards are in Article 408. However, 408.38 states that the panel boards are to be mounted in cabinets, cutout boxes, and identified enclosures. Okay, and again, those would be covered by Article 312. 312 covers enclosures. Okay, and shall be dead front. This means its enclosure will have a cover over the busing, terminals, conductors, and overcurrent protected devices. So a dead front cover, it's going to mount on top of it, hiding all of those components. For commercial installations, 3 different components are often selected: the cabinet, the panel board, and the cover for either flush or surface installations. For residential applications, enclosed panel boards, commonly referred to as load centers. Okay, so the whole thing is sides, back, front, cover, covers everything. Okay, and typically, like we said earlier, they're still panel board setups, but in residential, because of the nature of how they're designed, we typically call those load centers. But they're very similar, and a lot of the rules are going to be very similar, so don't let that throw you, okay? No need to have it throw you in any way. And they're sold all in one component. You buy it. You just buy the load center. Where a lot of times in our commercial applications, we have to buy the cabinet. We'd have to buy the load center because the breakers can be rather large. Okay, so we sometimes had to have a big cabinet in order to be able to hold the different types of devices, the overcurrent devices that we needed. And so we would piecemeal these things together and then have to get the right type of cover for it. And we had to work closely with the manufacturer. Whereas typical load center for residential, dude, I just go down to Lowe's, Home Depot, or maybe from Supply House, Gray Bar, or whatever, and just buy it. Okay, there you go. Let's see. In the past, panel boards were defined 2 ways. They used to be a lighting and appliance panel board and then a power panel board. Okay. But in 2008, NEC removed the differentiation between power, lighting, and appliance. So if y'all remember back, the old school folks will remember there used to be applications for lighting and appliance, and it limited the amount of overcurrent protected devices that could be in it. And then, of course, it had a power panel board, which did not have a limitation. Well, what happened is that was all changed. And so the maximum number of overcurrent devices permitted in a panel board is now governed by the design, the rating, and the listing of the panel board. Where in the past, when it was appliance, okay, lighting and appliance, it was limited to 42. And the power had a higher number. So by getting rid of that requirement in 2008, now it's really up to the manufacturer of the panel board. So you can buy one. You can even buy load centers now with 60 spaces. Typically is was typically a 2040, okay, which allow you to use tandems, okay. If you use full size 1-inch breakers, you can get 20. If you use a 1/2 inch or half size breakers, you can get 40. Again, the panel will tell you that. The load center will have that information in it, so don't worry about it. And you'll see a bus configuration, right? So there's a bunch of different offerings today, but the key thing to take away is that we don't have that 42 space overcurrent limitation anymore. That rule no longer exists, okay? So again, it's really dependent on the manufacturer. And I've seen some examples of 60 space load centers out there now from the manufacturers, okay? Right now, 408.36a stipulates that if the panel contains snap switches with a rating of 30 amps or less, okay, this is rare, by the way. I have not seen in a long time any panel board configuration with a snap switch component. Okay, so again, probably just more or less something you might see on an exam. Probably not something that I see very often out in the field, but y'all that do a lot of commercial, maybe you see these integral panels that'll have something like a snap switch in there, and they have to be 30 amps or less. And it says the panel board overcurrent protection is not permitted to exceed 200 amps. So where you have these snap switches that are rated 30 amps or less, then the overall protection for that panel board cannot exceed 200 amps. Okay, that sounds like that would be an exam question. Okay, that's something that you may see on an electrical exam than it would be more practical in real life. Let's see. So this provision limits the overall size of the supply side overcurrent protection due to the small switches and permits better protection for them. Okay, so it makes sense. So if I do have these small snap switch design, which again, I have not seen in decades, but if you did, then it's going to limit the amount of current that can be drawn for this this panel board. Okay, so again, that's not, when we say snap switches, we're not talking about the normal circuit breakers, normal panel boards with normal overcurrent protected devices. Okay, not the same thing. So don't get the two confused. Okay. Let's see here. What do we want to? We're not going to worry about these snap switches because again, it's very rare to see anything like that. So let's move on. All right, let's talk a little bit about the construction, just so we all kind of know how the construction. So in general, panel boards are constructed so that the main feed bus bar is run vertically for nearly the height of the actual panel board. From the top, where your breaker may be, your main breaker, or even main lug only, it runs from the top all the way down through the actual cabinet. Okay, all right. So the buses, the bus to the branch circuit protected devices are connected to the alternate main bus as shown in figures 12-2A and 12-2B. The bus arrangement shown in these types of figures are typical. So what do they look like? Well, there you go. So there's a typical one. Y'all see this is a typical single phase. Again, leg A, leg B. This is not phase A, phase B. Remember, single phase is just one phase. So you're just at each end of it. So it's not phase one, phase two, phase A, phase B. It's just leg A or line A, line B, whatever you want to say it. But it's still just one phase. Okay, and you see how it alternates. So number 1 and 2 on the same, they're on A. 3 and 4, it's on B. 5 and 6, A alternates all the way down. Okay, in a 3-phase setup, this is phase A, phase B, phase C, because again, the terminations are at the end of separate phases, the windings, whether it's a delta or a Y. Okay, they're at the end. So here, 1, 2 is A, 3 and 4 is B, 5 and 6 is C. Okay, so again, 7, A, 8, B, no, excuse me, 8, A, 9, B, 10, B, because they're on the same one, connected to the same bar. Y'all are familiar with this. Only thing I remind you is some people get confused with this kind of stuff when they go and try to use breakers and try to do things like if they're dealing in a system where it has a high leg, for example, and you have the same type of configuration. If you have a delta high leg, which is 208 to ground, then again, making sure that you're not sticking a breaker on that. Let's say a breaker that's only rated single phase 120. So it's important you're not using a single phase 120 to 40. For example, if you're trying to get single phase, if you're trying to get a phase to ground, for example, where it's 208, you don't want to use a slash rated that's 120 to 40, where the 120 to ground is going to be the maximum. and you don't want to put that on a breaker that it's going to be that's 120 to ground, but it's going to achieve 208 to ground, then you run the risk of damaging the device. Okay, so all right, so we've talked about that before, straight rating and slash ratings of overcurrent protected devices, and being very careful how you use them inside of a panel. Okay, very careful. All right, let's see here. Anything else I want to do? Okay. Let's see. Okay, yeah. So this is an example of numbering scheme. So here you go. So same thing here. It's hard to see this, but we'll show you the top part. I can zoom in too, just to kind of give you a better look here. So here you go. So here's A, B, and C. This is a three-phase panel, obviously. So here's A, and here's B, and here's C, right? And then you come down here. So these are open for any single breakers. And then you're putting a two-pole breaker. So in this two-pole breaker right here, and we'll just say this is a three-phase, 120, 240 volt three-phase. So here we're getting right here. So maybe this is or maybe even this is a 120, 240, a 120, 208Y. Okay. However, your configuration, you notice something important here is that B is the red right here. So these are being configuration right here in order to get the voltage from a phase to phase voltage right here. Here they're doing, let me scroll up. Here they're getting three phase right here. So you notice that the breaker is tapping both the C, the A, and the B in this configuration, right? So that's just how the configuration is. Let's see. Phase arrangement requirements. Okay. For those that want to know how the phase is supposed to be arranged in a panel, when you're looking at the panel, whether you're looking down from the top or you're looking at it from the front, right? So in a stacked configuration from looking down from the top, again, it's always A, B, C, A, B, C. So from left to right. If you're looking at from the front, it's A, B, C, okay? In this case, it's a double tapped front end enclosure, so it's an A, B, C, same scenario. Side view, okay? Looking at it from the side, right? So the front here being A, B, C. Looking at it from the top, A, B, C, stacking, A, B, C. This is the front. This is looking on from the front, and this is the front looking at it from the top. That scenario, okay? Incidentally, and we're going to show you this as well. Incidentally, most of your manufacturers already know this. The ones they build their equipment. Now, what can get wonky is if you're running the phases and you don't think about where you're putting things at, and you put the one that's on C phase downstream, you accidentally put it on A, yada, yada. You're going to learn real quickly. But again, they try to keep the markings consistent all through the different panel boards configurations, especially if you're doing the three-phase application. Let me zoom out a little bit. It's a little bit cramped up here. So this happens to be, you heard me talk about it a minute ago. So this happens to be a 4Y delta connected system. So this is a delta. And this is obviously 120, 240 volt delta. Why? Because we're mid-tapping one of the windings, one of the phases. So this is single phase, right? So when we're tapping this whole phase is being used to get you the 240 and the 120. Okay, so half of this is a 240 winding. From here to here, it's 120. From here to here is 120, right? So from measuring from here to here to the neutral, that's why you get the 120. From measure from here to here, that's why you get the 120, okay? But this is the single phase portion of a polyphase transformer, okay? All right, so this just has to be a three-phase 4Y delta, and you see it comes down to this panel. Notice that the neutral is being brought down, okay? If this is a service, for example, you still always have to have a neutral brought to the service. Now, people ask me this all the time. Do I need a neutral downstream to another panel or to another load? Not if the load doesn't require a neutral, but you do need to bring it to the service, okay? Because we do need to allow for current to get back to the source in order to facilitate the operation of an overcurrent protected device, okay? Need to complete that loop, if you will. All right, so this is your configuration right here. Here's your main bonding jumper, by the way, showing it different. Rather than putting a screw in here, that'd be too easy. So we're showing you a wire type. So you have to size this based on the size of these conductors. Y'all know how to do that. We've done that before, right? So that's how that's sized, right? Ultimately going to send you to 250.102C for that, okay? All right. All right, so anyway, there you go. There's our setup there. And this right here, because of this connection here, right here, measurement from here to here, that means this center one here, B, in this case, is going to give us 208 volts, right? As it is three-phase. So you take the 120 times 1.732, 208. That's where you get the 208. Now, the other interesting thing, and y'all know this, most of you do know this, well, that would just be an ungrounded delta panel. And typically, I don't see those on normal setups from a utility transformer, AJ, because we're required to bring the neutral to the service. Now, in a commercial environment, you may have a panel from a transformer that is an ungrounded system, and it would not. Now, you'd still have to have an equipment ground run, but this depicts a service because you see no equipment ground run here, and it's got the utility here. But typically in an ungrounded service, we would still bring a neutral down if it's a system that's required to be grounded. I haven't seen many ungrounded systems, but obviously if it's an ungrounded system, it's not going to have a grounded down to it. But those are very unique systems, usually for smelting plants like that are generally going to have an ungrounded system. And then there's going to be other requirements that they have to have, monitoring, notification, things like that. Yep. So that scenario. But those are very unique systems for very specific applications where they may have, again, monitoring systems, lighting systems. When they lose something, lights start going off. But where I see most ungrounded systems are typically there is a service to the building that does bring a neutral, but then they derive an ungrounded system from that system because they're going to be running things in a facility that they do not want to trip right away. They want it to be a bit delayed. So in doing that, they'll still have an equipment ground. They just don't have a neutral scenario. Still going to have the equipment ground. But in that case, it allows for the system to run a little bit before they have a major problem. Okay. Let's see here. Oh, by the way, it is also important to note that when you do have this system, high-leg system like this, you do have a label that you will have mounted on the panel. I don't know that if you buy these panels, I can't remember whether this is already on there or not, or you have to put the label on there. I literally can't remember. Anybody out there remember? But there is a requirement that it be marked, and it tells you which phase has the 208, okay? That type of thing. What is it, Miguel? Is Miguel taking an exam today? Oh, Miguel has a test today. Miguel, good luck. I think you'll be successful. Just study, focus. Remember the three-wave method, right? Three-wave method. Go through and answer everything you know right away. Mark the ones that take you a minute that you don't know. Mark it, right? And get that on the second wave. Go answer all the ones that you marked. If you answer it, uncheck it and keep going. Spend about a minute and a half on the second wave. And in the third wave, any that's left checked, spend another minute on those. And if you answer it, unmark it. If you answer it and you're still not sure, leave it checked and go to the next one after about a minute, because you're going to continue to work on those unless you just run out of time. But you don't, on the third wave, you want to make sure you answer the question. Whether you uncheck it or not, you want to at least make sure you answer the question, whether you're making an educated guess or not in the third wave before you go on to the next question. You want to make sure that you don't end up with any questions that are blank, because they're going to be wrong if you do that. You know what I'm saying? All right. Let's see what else we got here. What else we can get into? Numbering of circuits. Let's see here. I don't think there's anything I want to get into today. Okay. Typical Panelboards, and I don't know why this is so large. There we go. Typical Panelboard ratings are available: 60, 100, 200, 225, 400, 600, or even greater values. I've done some 800 amps. I've done some 1000s. I've done some 1200s. Okay. The rating is determined by the current rating capacity of the internal main bus in the panelboard. So they're going to evaluate the panelboard itself based on the busing setup, the size, the copper or aluminum, however it is. They're going to make sure that when they do all this evaluation, there's nothing you have to do. You ain't got to do anything. you buy it that way. But I think you should understand that you see that there is an AIC rating if there's an overcurrent device, and then there's an SCCR rating on the actual equipment. So the SCCR rating takes into consideration the entire rating of the panel board, right? So in this case, the ratings are determined by the current carrying capacity of the internal main bus. That's the panel board, the guts, okay? After the feeder capacity is determined, the panel board rating is selected in compliance with NEC 408.30, which has a rating not less than the load calculated in accordance with 220. So what that means in fancy slang, okay, fancy slang we like to say, what that means is you're obviously going to select your panel based on your load calculation. I mean, that's a no-brainer. If I calculate 210 amps worth of load, then I'm going to be going to a 225 amp panel, right? And that means that the guts internally is all going to be rated 225. And that's already going to be determined by the manufacturer. The only time as a commercial that I got to be careful is as I'm piecemealing this. So if I'm doing a cabinet and I'm buying panel boards guts separately, okay, and of course our covers separately, then I need to make sure that the panel board guts that I'm buying, again, are of capacity and rating to handle whatever the calculated load is that we calculated during an Article 220 calculation. Well, when we buy a load center, it's already done. We already know all this. We buy a 200 amp panel, that's it. Everything in it's rated 200 or 225 typically, even if it's a 200 amp rated panel. The guts and internally is probably going to be rated something like 225. Go check out your 200 amp panel. Let me know in the comments one day after this video plays. Let me know what's in your 200 amp panel. Does it say the bus and all is rated 225? Let me know in the comments. All right. All right, so overcurrent protection scheme. Here you go. This is a good example right here. Panel boards with overcurrent protection in each panel or on the line side. Okay, so here's an example. So here's a 400 amp overcurrent device, right? And you see that's coming down. There's a 400 amp rated conductors coming down into a wireway. These are doing feeder tap. Oh, shoot. I'm not showing you the lesson. Sorry. So here is an example. This is a neat example. So this is your 400 amp protection for the feeder, right? Right here. Oops, let me shut this down. Right here. So we're just using fuse here to break it up. Could be a circuit breaker. It doesn't really matter. So it's coming in. Here's the feeder. It's going into a wireway. Now you've got some feeder taps right here. So these feeder taps are following the rules. These are probably 10-foot taps. So it's following the feeder tap rules on 240.21b. By the way, if you don't know how to do that, here you see 200 amp, but you see that the panel board is rated 225, but the main is 200. I think that's typically what you get, right? So anyway, so these feeder taps are sized using the 240.21b rule, right? And we have a neat video on this over on Fast Tracks Tube, by the way, where I show you feeder taps and talk about the feeder tap rules. So this is a neat illustration. One day we could just really break this picture apart if you wanted and just throw some examples on how we would do this in the real world. This might be an enclosure. This might be just a single disconnect. It might be a breaker. It might be a fuse in a panel. And then it comes out with EMT, let's say, and we're running the 400 amp rated conductors out into this wireway, and then we're coming out of this wireway. Here's our feeder taps. There's no protection at the tap. That's why this is a feeder tap conductor. It comes down and terminates into this overcurrent protected device. This follows the 10-foot rule. We'll assume these are the 10-foot rule because it is 240.21b, right? But notice this one isn't. Notice this is a 400 amp rated conductor, right? And it's coming down. It's in the same building, and it has no main on it. But it is a 400 amp rated panel board, okay? So if the feeder overcurrent device does not exceed the rating of the panel, then separate main overcurrent device is not required in this panel. Is this not neat? Let me blow it up a little bit. This is it. Let this blow your mind for a second. That I've got this one feeder, and again, you still have to do a load calculation because I know what somebody's saying. They're saying, wait a minute. How the hell can I have a 200, and a 400 on it? That's, how in the world could I have all this? Well, again, it's all based on the load calculation, right? So you have to know the load calculation. You don't just add up the breakers, folks. So in this scenario right here, tap, tap, and this is full size, and this would be full size. This would be the same size as this 400 amp conductor. This would be the same size for the 400. Basically, it's just an extension. This is not a feeder tap. Okay. It just continues on. Right. And in this case, I don't need the main breaker. Why? Because I have the breaker up front right here. Okay. These are meeting the breaker. This has the fuse because of the feeder tap rules. Okay. What's up, David? What does David say? I'm sorry. Good morning. Just got home from having breakfast with the man that hired me 25 years ago. Boom. Bill Pancake. Oh, Bill was there too? Cool. Cool. I saw Bill was at Code Panel 5 meeting we were at. Yeah, Bill's a great guy. All right. So anyway, so this is just a neat illustration. One day, maybe in coffee hour, if y'all want, we'll go over that illustration. I mean, go over and kind of do some extra math. I think it's pretty cool. This is the kind of shit we talk about here on Coffee Hour, guys. We just have a fun old time. Here's an example right here. Panelboard without a main. It utilizes 408.30 and it uses 408.36, which means it has the protection upstream. So let's see what this one looks like. So this one says the overcurrent protection sized at the ampacity of the conductor. So 240.4 and not greater than the rating of the panel board. Okay, so this is a switch, 200 amp rated switch that's fused at 150. And this is a 150 amp rated conductor capacity. And it's going to a 225 amp panel board. That is perfectly okay. This freaks people out. Now, if it was the other way, if this was 225, then this cable would be, a conductor would be rated for 225. But if this was rated 150, that's a no bueno, right? So it has to be at least equal to or greater than the overcurrent protection. And that's what it's talking about in 408.30. And it meets the protection requirements of 408.36. That's pretty cool, right? Now, here's that one we were talking about earlier with the snap switches in it. So check these out. I don't see these very often at all. But look at this picture here. Let me blow it up a little quick. So this is what it's talking about. If you happen to run into one of these panels, fusible panels, right, that has a fuse in it, but has these switches in it, okay, then this is saying, all right, this is fine. You can do this scenario. These fuses can exceed, these rated fuses, snap switches can exceed 30 amperes, and the overcurrent can exceed 200 amps right here. Okay, pretty neat, right? If you run into those type of scenarios. I have not seen one of those in decades, to be honest with you. All right, let's do some giveaways. Just a good information today. If you appreciated it, love the thumbs up. Share it on all your platforms. Share a little love. I go all over the place. This is not part of any lesson. This is just coffee hour. I have a lot of people that comment and say, well, you went all over the place. Your lesson. This is not a lesson. This is coffee hour. We talk about all different types of things. Whatever pops into my head, I like to talk about. And you may agree with it. You may disagree with it. Let me know what you disagree with by going over to paulabernathy.com and submit it there. It's okay. You cannot hurt my feelings. Okay. I'm just trying to have a good conversation, enjoy coffee with my fellow electricians. All right. So let's do some drawings here. What does this say? It says, I think you should video bio the CMECP and share how they got started and failures. Oh, any of our CMECPs? That's a great idea. I'd love to have them on a show. Okay, so CMECPs out there, if any of you want to be on a show and talk about your story and how you got into it, let me know. We'll have you as a guest on a coffee hour. Or if you'd rather do a separate video, that way if you feel like you might mess up or you're a little nervous, then we can record it. But yes, I'd love to have some bios from our CMECPs. If you're already on here, let me know. I'd love to get you in a bio. Let everybody know how you got started and maybe why you chose electrical and went this path and those type of things. All right, let's spin the wheel. Give away some goodies here. I am running over, so we'll just do 3 today. I'm sorry. Bill, I'd love to have you. Email me, Bill. Email us info@cmecp.org. Email me. We'll get together. I'd love to have you on the show. All right. David Carter. David Carter, you're in the drawing for Trade Hog. By the way, Trailhog is now annual, so you can choose annual memberships for those that are interested. And the light one is the best. It's just over $100, and you don't have to worry about no monthly fees. You get it, you got it. And if you do it monthly, it costs you a lot more than doing the annual. So that's now available. Some people, only the light will be all they need. They don't want the back end. They don't want the Office Hog. They don't want the mobile app. All they want is just to be able to go to the web browser, boom, when they're on the job. Sometimes that's all you need, okay? New low prices for that. All right. So, David, we got you down. Let's go. People on TikTok, and everybody's still watching on TikTok. Yes, I got a few people on there. Hey, TikTok. We were all over the place with feeders today. All right. Let's see, Paul. Let's see. Montoya. I think you registered for Trailhog yesterday, but remember, you get multiple chances. So we'll put you again here today. I think you registered for got registered yesterday for that as well. But yeah, never hurts to be registered again. Increases your odds. You know what I'm saying? Most want to be like Mike, but you want to be like Thomas. Tom, you want to be like Tom. Be like Tom. Don't be like me. You'll be bald, fat, ugly. Don't be like me. What's up, Eddie? All right, Eddie. I don't know, Eddie, are you already in the Fast Tracks tube? I'm not sure, but if not, go and sign up for a free membership over on fasttrackstube.com. Let us know. We will elevate you to an annual membership. Let's see about the... Red Dog says, yeah, I explain a little bit more about the AIC ratings, and you say how they differ. I'm not sure I understand that part of it, but I mean, maybe you mean the difference between 110.9 and 110.10, the difference between a SCCR rating versus the KAIC rating, K just being thousands. So amp interruptive rating capacity. It's the AIC is the rating of an overcurrent protected device, how much it can handle before it would blow up in your face. Okay, so what is the amount of current that it can handle? Not the rating of it tripping, but the amount of current they can handle during a fault condition and still be operational and not blow up or blow out into some user's face, right? That's what that really is. That's the crux of it. I encourage you to go read 110.9 and 110.10. Now, an SCCR rating, the SCCR rating is the short circuit current rating. It typically applies to the components in a cabinet or equipment, the buses, the cabinet, everything in its configuration. It gets rated for that, and it gets an SCCR rating. So again, it is what it can handle and still be operational on something like a fault. So when we get something like a fault calculation or available fault current that's supplied by a utility, for example, then what we're doing is looking at a rating, and we're making sure that if they tell us that they're going to limit us, for example, to 10,000 of available fault current at our equipment, then what that does is that tells us that if I have a panel of service, I have a main breaker, if it's good for 22,000 AIC or 22K AIC, then it can handle 22,000 of this fault current. And so if the utility tells me the available fault current is limited to 10, then obviously my 22 is higher than the 10, and I'm okay. Right? But also when it comes to SCCR, we make sure that the equipment is rated to also handle that available fault current, and it typically will be equal to or greater than the rating of the AIC rating of the overcurrent device. Now, you can get series ratings where you actually will have, for example, a service and they tell you it's going to be 18,000 of available fault current, right? And the main breaker is 22K. That's fine. But each individual breakers underneath it may be only rated 5K or even 10K. That's okay as long as it's series rated. So those breakers that are the circuit breakers on the bus bar, they're rated in conjunction with the main breaker. So if the main breaker is rated 22,000, then it's going to basically be okay for the breakers underneath it to be less than that. Okay. So that's important to make sure you understand the difference between whether or not you have something that is series rated when it comes to the breakers, and it means that they're in conjunction with a main breaker designed that way, that type of thing. Just remember, SCCR is more about the equipment, internal guts, things like that, okay? We don't promote other people on here, Jonathan. What are you doing? Don't make me ban you, bro. All right. So anyway, so that's kind of a short and skinny on how it's done. Okay. Eddie, again, I don't know, Eddie, if you have this or not, whether you're still here or not, but we're going to put you down, Eddie, as Fast Tracks Tube. And if you have it, great. Not, let us know. Okay. No, you weren't. You're promoting Electrician U. Don't promote that dude. I'm just playing. Dustin's fine. All right, let's do another one. Just teasing, Jonathan. Just teasing. I like Dustin. He's all right. Go to electricianu.net or .org. Electricianu.net or .org. I see where that sends you. What's up, Greg? All right, Greg Converse, you have one instant win wire waffle, but something makes me think we've sent you a wire waffle. So pass this on to somebody else. If you did, we'll spin again for you. If you already have one, we don't want to become a supplier of wire waffles. We just give it to people so they can try them out. So if you already have a wire waffle, Greg, we don't want to send you another one. Okay. All right, real quickly, just so you guys, because I told you about it, I just want to tell you there. So that's your homework. Here's your homework. Homework is for you to go over here to 110.9 and 110.10. Okay, this is your homework. Okay, interruptive rating. Equipment intended to interrupt current at fault levels shall have an interruptive rating at normal circuit voltage at least equal to the available fault current at the line terminations of the equipment. Okay. Now, if I click this down here, for example, fuses and circuit breakers that do not have adequate interrupting rating could rupture while attempting to clear a short circuit. Okay. So the interruptive rating of an overcurrent protected device is determined under standard test conditions. The rating should meet or exceed the actual installation needs. Interruptive rating should not be confused with short circuit current rating, which is what I just talked about a minute ago. So typically this interruptive rating typically is going to apply to circuit breakers and fuses or other switching components. And then this one here is 110.10. Okay, this is your circuit current rating. And this says the overcurrent protected devices, the total impedance, the equipment short circuit current rating, and other characteristics of the circuit shall be protected and shall be selected and coordinated to permit the circuit protected device used to clear the fault to do so without extensive damage to the electrical equipment or the circuit. The fault shall be assumed to be either between two or more circuit conductors or between any circuit conductors and the equipment grounding conductor. That'd be a ground fault, whatever. Okay. It says listed equipment applied in accordance with their listing shall be considered to meet this section. Now, if I click down here, you see where it says short circuit ratings are marked on equipment such as the panel boards, switchboards, switchgear, busways, contactors, and starters. Okay. It says listed products are subject to rigorous testing as part of their evaluation, which include tests under fault conditions. Therefore, listed products used within their ratings are considered to have met these requirements of 110.10. Okay. Okay. So again, long and short of all that is to make sure that typically I like to get you in your mind. The AIC rating is based on the overcurrent device, and the short circuit current rating is based on the equipment and all the components. Okay. There you go. All right. Eddie says I've already got it. He wants to spin again, so we're going to spin again for Eddie. This is for Eddie. No music, Eddie. All right, we'll give you music, Eddie. Eddie. Let's go, Eddie.
Woo, 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 woo. Big dog.
All right. Eddie, you're in the drawing for the new Slate coasters. I should have one next week to show you what it's going to look like. But you're in the drawing for those. The drawing is on September 30th. And Greg, I don't know what we picked for you. Be honest with you. I can't remember. I didn't see what it is. So Greg, if you're here, would you like to also be in the drawing for the new Slate coaster? The new exclusive Slate coaster for electricians that we're going to be putting out. Will you want to be that? Greg, do you want that? If it is, I will put that down for you, my friend, and not even have to spin the wheel if that's what you'd like. The coasters are going to be neat. I'm going to have one here on my desk. And I'm certainly going to have them up on my coffee table because I do not want to screw up my wife's new coffee table. I'm just saying. All right. So anyway, we got you a slate coaster drawing. Again, the drawing will be September 30th. All right. Greg, if you're still here, let us know what you want. But other than that, we'll just go back to the chat. So Miguel, again, good luck to you, Miguel, as well. Hopefully you nail that thing today. Focus, focus, focus. Focus, focus, focus. It's your wife's birthday today, Tino. Happy birthday to Mrs. Tino. Make it a great day. Take her out to dinner. Treat her like a queen, okay? Behind every good man is an amazingly awesome woman, okay? And if you become an awesome man and an awesome woman behind you, dude, there ain't nothing you can't not do. I'm just saying, the world is your oyster. All right. All right, Greg, I'm going to go on and put you down for the slate because I didn't hear from you, so I don't know if you're still here. So I'll just go on and put you down for the slate coaster. And you'll get in the drawing for the slate coaster. All right, guys, I'm going to let you go. I know I've taken all your time up today. We went through a lot of things today. We were all over the place. That's what Coffee Hour is all about. If you don't like it, or you're one of those that saw this and run back to the YouTube channel and whined about it and say, Paul's all over the place, Paul's all over the place. And guess what? Stay over there on Facebook or wherever you're at. You know what I'm saying? We don't want you here. Till next time, stay safe. God bless, folks. We'll catch you Monday on a Coffee Hour. Have a great holiday weekend. Happy 4th of July to everybody. Happy birthday, America. Till next time, stay safe. God bless. I just got to say real quick before I go, Tino, that's a damn good woman. Hold on to that woman. If a woman is wanting a brisket, and 16 hours sounds about right. I used to cook a lot of briskets. That's a good woman. You need to keep that woman. Okay? If she allows you to mess with that smoker for 16 hours and keep an eye on it and stoke that thing and keep that thing going, or you could be lazy like me. I had a pellet smoker. I had a Rectech, and boy, I had an app on my phone. I could do what I want and just monitor the app. That ain't the way it used to be. It used to be I used to have an old stoker with the wood in it and do that stuff. I modernized. So now when I moved, I sold my entire Rectech for, I think it was like $500. It was like brand new, stainless steel, big Rectech. I don't have a deck here at this house yet. We haven't put a deck on it yet. When I do, I will be getting my smoker and I'm going to get back into smoking some meat, baby. Smoke that meat. All right, next time. Stay safe. God bless. Good woman. Hold on to that one. Peace.